Here I have a project. It's a very smart project. It's probably among the top 2 to 5% smartest pieces of C# code you have ever seen. I wrote an article about it in 2019. The code base is 5 years old. Have that in mind. It's using Inject. It's using ASP.NET 2.2. It's using Hibernate. It's using Mapster and Swagger. Let me show you the project, because what I want to illustrate is the differences between creating code in HyperLambda, which is my programming language, and creating the equivalent code in C# and ASP.NET. But before we do, let's count how many lines of code there are in the project in total. There are 2,392 lines of code. And the project has, if you build it and run it, then the project has one single entity, which is a to-do entity that you can persist into your database using the basic CRUD axioms. So first, here's the program guide that uses a startup class. Now, have in mind that this code is 5 years old. There do exist better ways to accomplish this today, but the basic foundations of what you need to do are the same today. So there are no really significant improvements related to C#, even though Microsoft has added some syntactic sugar on C# since, and there might exist better IOC libraries to use and better mapping libraries, and you can use Entity Framework instead of and Hibernate, etc. So the project is created with a database first approach, and here you can see how it's configuring the project. As you can see, it's reading configuration setting called plugins, which you can find here, which allows me to dynamically load up plugins as the project is initializing. And each project is expected to contain a service, service interface, and a controller. So if you look at the code here now for the example controller, you will see that it has one controller called to-do, which has one class that implements the initialize interface, allowing the core of the project to run through this initialization process. This is how you bind interfaces to services using Inject. As you can see here now, we have an interface, to-do service, and then we have a class that implements that. Now, part of the point about the project is that it's super dry, so it's dependent upon generics. As you can see here, I inherit from CRUD service, which is a generalized reusable service class, allowing me to pass in my type here. So now if I look at to-do service, you will see that it again implements iCRUD service with DB model being its generic argument, allowing me to generically create functions such as create, delete, get, list, and update. Basically the 4 basic axioms for CRUD, including count here. So now if I go back to to-do service, you will see it implements to-do service, which again is just a generic interface that declares the different methods. So now at this point we have basic CRUD without filtering, I need to emphasize. And if we want to filter, let me see if I can find the CRUD service here, then basically what we, not the CRUD service, but the to-do service, what we need to do here then is to create our own method and expose it as inside of the to-do interface. So now we need to update the interface, we need to update the service, and we need to update the controller. 3 different files now to add one simple method to the project. And this project is using all the so-called best practices we're taught in the software development industry. Now, if we go further into the project, we will see that it has a model, right? So now if I go into webmodel.common, here you will see it's got operation result, which is a generic reusable web model or view model. that contains a message and an ID for which is optional for whatever object was affected. If you look at specifically the to-do web model, you will see, okay, it's declaring ID, header, description, and done. And the way this is mapped up here now, if we go into not the web model, but we go into, let's see if we can find the to-do controller, the mapping parts model here. As you can see here, it's mapping up okay, there's a syntax error here, it doesn't matter, the code is correct still nonetheless, it might just be a missing reference or something. And it is using the model first theory for the ORM library, where it's basically mapping an existing class towards the database, ensuring that we can do stuff that automatically creates the database if required, based upon your database model. And then if you look at the to-do guy here, you will see it inherits from model, which implements public virtual GUID, so it assumes the database primary key is always ID. Now the point about showing this project, first of all, there's a link in the description to where you can download it. You need to download version 1.1 of Magic. Now the point about showing this is because this project shows probably top 2% quality-wise C# code you have ever seen in your entire life, related to creating a dynamically and extendable CRUD basis to be able to create HTTP web APIs that are accessing the database. And when you add a new table to the system, you need a new view model, you need a new database model, you need to map that database model, you need a new service interface, you need a new service implementation, you need to map that service implementation in your IOC container towards the instances of the interface. You need to create a controller. I'm not even sure if I even mentioned that, but you're up to basically having to touch 10 files to add one simple table to your code. Now let me show you how I would do that in Hyperlambda. You see, I started this project in 2019, and it basically was started because I needed some code to write an MSDN article. And at that point, I'd kind of like given up on Hyperlambda and my own ideas related to architecture, realizing that the world just simply wants to be deceived. So I'd started coding in C# again, and I wrote a couple of articles related to C# for Microsoft that was published on Microsoft Developer Network, MSDN. So now let me show you how I would do this in Magic using Hyperlambda. Here I have a cloudlet. First we're going to need a database. Let's call it to-do. Let's edit it and add a new table. Call it items. Let's add a new field. Call it title. Let's add yet another field. Call it description. And now let's go to create endpoint generator, choose this database, and we're done. So from 2,300 lines of code to 200 lines of code. And this code took me 3-4 days to write and architect and think about. This code took me how many seconds? 25 or something. And this code actually has tons of features that the original code doesn't have. Specifically, it's already got, among other things, filtering on the read endpoint, allowing me to retrieve items according to my filter arguments here. Title like, title EQ, description like, description EQ, item ID, EQ. EQ means equal. In case you're wondering, I can sort, I can limit, offset, and order, and stuff like that. So I went basically from 2,340 lines of code to 200 lines of code. I went from 3 days to 20 seconds to implement the code. This code has 100 features. the original C# code didn't have. If I want to add filtering on this guy, for instance, then what I first need to do, I need to go into the to-do controller here, and I need to add another HTTP API method. Then I need to change the interface here. Let's see if we can find the I-to-do service here. So I need to add a method here that I'm implementing in the, let's see if we can find the services here, magic service to do. Then I need to implement that method in this class, and then I need to create a new model for my filter arguments, etc., etc. So you're looking at, to add a simple method into an existing controller, you're looking to touch upon roughly 5 different files. To add a new table to the system, you're looking at having to touch approximately 20 files. Let me just, for the record, go into my database here now, SQL Studio, choose my to-do guy here and create a new table and call it contacts. Right, and then let me create one field in it, name, just to illustrate how I would go ahead to add a new table to this code. Endpoint generator, I choose my to-do database, I drop all tables and only generates for endpoints or contacts here. Click generate, I go back to HyperID, 187 lines of code automatically generated for me. My existing code was not touched at all. However, now I get contacts, get post, put, read, update, and delete, in addition to the existing guys I had for items. Now, when you're done with that C# code, which is the bare minimum you're going to need if you want to do some database access in an HTTP web API, then to further the insult, you now have such huge amounts of cognitive complexity in your code that you will need unit testing. So you're going to have to create unit testing. Since it is indeterministic code, you're going to have to apply some sort of like mock library and create mock objects for your service implementations. Then, because now you have unit tests, and you probably want to have some sort of like integration test using some sort of like integration test framework, you'd probably want to have multiple different branches, like a dev branch, a QA branch, and a release branch, or something like that. At which point now you're going to want to add pipelines to it. So now when you have pipelines, the project's complexity is so big that you'd probably want to have multiple individual resources, implying human beings and software developers actually touching upon the project. So now you have like 3-4 developers, a DevOps guy, maybe a PM guy, maybe some 2-3 developers to maintain the code, at which point you do want to have a pull request policy, you know, bothering every single developer on that project for every single commit you push upstreams, forcing these guys to actually review your code and accept it before it's merged into the release branch or whatever, etc., etc., etc. Now you need unit testing, you need Git, you need workflows, you need DevOps, you need unit tests. I don't. The code you saw me creating in HyperLambda is in production. It's already in production. When I click save, it's freaking in production. And it cannot, not even in theory, contain errors. Because I didn't write the code. The machine wrote